So, explanation for that last video as far as the graph getting scratched out. Somebody walked in and I ended up stopping the video, so I'm going to just keep going with this one. That should have been enough for transformations. Now I'm going to do a little bit on domain and range. So starting right here, again, set builder notation is the one that you start with. Let me see if I can clear that up some. There we go. You start with the set. So we're talking about x values. This is horizontal. So x values, this is domain. You start with a set of all x such that, and that's exactly how you say that. It's a set of all x such that, and then you pretty much just put an inequality here. So notice that the values go from -2 to 1 without touching -2. So -2 is as small as it gets. So x is strictly bigger than -2. But x is smaller than or equal to 1. So notice all the x values are between the values -2 and 1, just like you see right here in the inequality. Then you go ahead and close that off in a set. Now on the test, I think they're just going to ask for the inequality, which is just that portion right there. They're not going to ask for the whole set builder. So maybe consider yourself lucky, but I would still encourage you to learn set builder notation. You're going to see it later if you go into more advanced math. Interval notation, this is the easy one. So remember, if it doesn't touch a point, then you use a parenthesis. So it starts at -2, it goes to 1, and if it does touch it, you use a bracket. So you just say x is in the interval -2 to 1, just like that. So again, set builder notation. I'm going to go ahead and do it. It's a set of all x such that x is smaller than -2. So x is smaller than -2. Notice this arrow is going to the left where all the smaller x values are. So it's smaller than -2. It's also bigger than +1. So when you have two separate intervals like this, you say or x is bigger than or equal to +1. And then you just close that set. So again, here are the two inequalities that you're probably going to be asked for on the test. As far as interval notation is concerned, you just say x is in, and then this is going from -infinity all the way up to -2 without touching either of them. So you use parentheses on both. And then to start the other one, you put a little u here that means union. It's a union symbol. And then it starts back up at 1, so that's a bracket starting at 1, and it goes to +infinity without touching it. Okay, so those are interval notation, set builder notation. I would familiarize yourself with those. You're going to see them on the test. Determine the domain and range of the following graphs. Okay, so again, domain, where I'm going to write, I'll do a little bit of both. I'll do interval notation on this first one. So my domain, my x values start, the smallest one it starts at is right here at -2. And to make it easier, what I'm saying is all my x values, I'm not hitting the graph yet. Still not yet, not yet, not yet. Right there is where I start hitting the graph, and that's at -2. So because I'm not touching that point, it's an open dot, I'm going to put a parenthesis, -2, and then it keeps going along. I still have x values. So this is all x values, and there's an arrow. So as this thing keeps going, the x values are going to increase. They're just going to keep going as well. So my x values are going to infinity. My domain is all the x values from -2 to infinity. My range looks like it has the highest points of, again, using this straight edge, that's where I start hitting the graph. That's the highest point, 2. And then it goes all the way down to, well, there's an arrow right there, so it means it just keeps going down. So highest point of 2, lowest point of -infinity. Usually when you write interval notation, you go from smallest to biggest. So -infinity is smaller than 2. So I start at -infinity, go up to 2. All right, next one, the domain on this function right here. Let's do set builder notation. So it's a set of all x such that x can be between -4 and 0. So notice my x values starting right here go from -4 without touching it all the way up to x equals 0. X equals 0 right there. So x is between -4 and 0, or starts back up at 2 and never touches, it looks like, 2, 4, 5. It's a lot of writing for set builder usually. So it's saying that x goes from -4 to 0, doesn't touch -4, hits 0, and that's why you see that less than and then less than or equal to. Then it's greater than 2, so it's greater than or equal to 2, but less than 5. Again, if you're looking at these inequalities, notice that x is between -4 and 0, between -4 and 0, all those values, and between 2 and 5, all these values. The range, well, all I have to do is actually write one of these because it looks like the range touches the value. Lowest value is 0 without hitting it, and then it keeps going up, and it hits all these values for the range, and then it stops at +4. So it's the set of all y's such that 0 is as small as it gets. So y is bigger than 0, but less than or equal to +4. Okay. Going to go ahead and stop there just for the sake of time, and let's see what else is on this page. Okay, this is a good practice. I'm not going to write out the domain. Oh, well, no, that's not exactly what I was thinking. This is just sketching the graph, and then... So that's easy enough. I'm not going to worry about that. Find the range given the specified domain. That's kind of important. So if it gives you specific domain values, these are just x values. It's saying what are the y values. That's it. So I'm going to put another set, and then I'm going to plug this into the function. So -2 squared is going to be +4. +4 times 2 is going to be 8. 8 plus 3 is 11. So the range value that corresponds with that -2 is 11. So I'm going to now use the 1. So 1 in for the x. So 1 squared is going to be 1 times 2, which is 2 plus 3 is 5. And then I'm going to use the 3 for the x. So 3 squared is 9. 9 times 2 is 18. 18 plus 3 is 21. And it's as simple as that. Those three range values correspond to these specific domain values given that function. Okay, this is the one that I'm going to do very quickly, and it's kind of an important concept. So if I'm going to graph this, it says 2x plus 2. So it starts at 2, and then it goes up 2, right 1, up 2, right 1, up 2, right 1, that, and then I'm going to put an open dot right here. And the reason I'm putting an open dot right there is because I noticed that it only wants me to graph it from my x value at -2. So here's where x equals -2. So I'm as far left as this domain wants me to go. This domain has restricted me to go. So I can't go any further left than that. And my line goes up through these points, and it stops right here at x equals 3. This is where x equals 3. So that's my line with the given restriction. So the range now, given that domain restriction, goes from -2 up to +5, 6, 7, 8. So from -2 without touching it, up to +8. And it is a closed dot up there, so I use a bracket. Let's see, next page. Something important, let's see. Name 4 parent functions whose domain is all real numbers. I'll just name 2 real quick. Absolute value, because it looks like this with arrows. That means it's going from -infinity to +infinity for the x values. And let's see if I can think of another one that's not so simple. Oh, well, there's an easy one. But it's not as, I was going to do the linear, but I'd rather do quadratic. The quadratic function looks like this. So it keeps going left. Even though it's increasing a lot faster than it's going to the left, it's still going infinitely far to the left and infinitely far to the right, so its domain is also all real numbers. Here's the absolute value parent function, restricted from -3 to +2. Positive 2 is an open dot. Negative 3 is going to be a closed dot. And this is the reason I can do this so fast, guys, is just familiarity with these parent functions. But it's like that. Goes from negative 3 to positive 2, touches negative 3, doesn't touch positive 2. Touches negative 3, doesn't touch positive 2. And it's the absolute value parent function. This right here, so it's talking about, let's see, arrow being shot into the air, starts at 0, 0. After 0.5 seconds, it is 28. So this is all estimation. It looks like 1 is 48, somewhere in there. 1.5 is 60. 2 is 64. 2.5 is back down to 60. 3 is 48. 3.5 back down to 28, then back down to the ground. Something like that. It's a parabola. What is a reasonable domain for this function? Well, knowing that you're shooting the arrow from the ground and then it's hitting the ground, it doesn't really make sense for this thing to keep going down into the ground. I mean, maybe it gets stuck. Maybe it goes 3 inches into the ground, but it's not going to go 60 feet or anything like that into the ground. So a reasonable domain would be anywhere from the time that you shoot it, the arrow has a location, and then all the way to the time that it hits the ground, which is 4 seconds later. It doesn't really make sense for you to say that the arrow is in the air from 0 to 100 seconds. I don't know anybody that can shoot an arrow that high anyway. And also after 100 seconds, let's see, in this case it would be way far underground. So that wouldn't make sense. So reasonable domain and range, that's kind of what they're looking for right there. Noticing that the arrow is in the air only for 4 seconds and then it hits the ground. So from 0 to 4 is kind of what they're looking for. Familiarize yourselves with these parent functions. You're definitely going to have 4, 5 questions on parent functions. Know their equations, their domain and range. You guys were good at this on the test, so you should be fine unless you have forgotten it. I am encouraging you definitely to look at those parent functions. Inverses, super quick. Hopefully it hasn't been too long. Actually, I'm going to pause right here and make another video.